Welcome everyone to another USA Tech Talk. Today we are really lucky to have Mitch Buchanan and Jim Kunkel from Henkel with us today. Mitch is a protective coatings and MRO specialist with Henkel focused on asset integrity solutions for the general industrial and infrastructure market. Mitch is a U.S. Navy veteran with industry experience in chemical plant maintenance and operations along with coatings, adhesive, and composite formulation development expertise. Jim is a certified protective coating specialist, and his work with Henkel is focused on midstream new pipeline construction, repair and rehab. Also, Jim is the SME, or the subject matter expert, on above ground storage tanks in the USA. So from there, I'll let you guys take it.
Yeah. Thank you, Chris and Doug, for hosting this and having us today. It's good to finally be on one of these and get to talk to your customers and the broader audience here. So as Chris said, Mitch Buchanan with Henkel. I'm going to run through the presentation here and then open the floor for Jim and I to answer any questions you guys have. So we'll start with a quick safety share, talk about who Henkel is, because you guys probably know Henkel as Loctite, but you don't know Henkel as coatings potentially. So we'll talk about why and how, and then we'll go through some generalizations on high temperature coatings and some of our key solutions that we can provide you as an asset owner. So I always like to start a meeting with as a safety share. It's a habit I picked up when I was part of Huntsman. As Peter Huntsman always said, our license to operate is being safe. I don't know if you guys follow the news, you've seen some tragic incidents, including fatal incidents over the past couple of months. So one thing we can all relate to, right? June is PTSD Awareness Month and May was Mental Health Awareness Month. There's the National Association of Mental Illness, NAMI, lots of stats on there, adults, children, adolescents, right? This is something we should all talk about and be open. So how can we kind of help each other, talk to each other, remove the stigma, right? If you have a broken bone, you're going to go to the doctor. Just had the first one of those in my house last month. So for my kids, and it's the same thing, right? If you have a mental illness, you guys having bad anxiety, depression, can be really anything. Doesn't have to always be super serious. It can just be something that's affecting you maybe a day, a week, a couple of months. And so one thing we can do to help each other be the best versions of ourselves, right? Show up for each other, be open to each other. One of your associates, colleagues, boss, subordinates is having a bad day. Don't jump to conclusions and try to make everyone move forward together. So who are we, and why is this why Henkel now? So Henkel made two major acquisitions in this market in 2024, closed and fully integrated now. We're all Henkel employees now legally, but they bought Critica Infrastructure, so Clock Spring NRI Pipeline, and they bought Seal for Life Industries. So Seal for Life, main products we're going to be talking about today, was a coatings conglomerate focused on field joint coatings and infrastructure coatings. So Power Creek, Canusa, Andoflex, Stopak, Mosscoat, Highland International, lots of brands you recognize into this high temperature space and pipeline coatings. We're now all part of the Henkel adhesives technology, right alongside Loctite, Torojon, Bondurite, Norback, a lot of legacy product lines from Henkel as well. So, and our shared vision is build and maintain and protect your critical infrastructure, and we're now part of what we call infrastructure protection and repair. So Henkel IPR, if you see that around, that's Jim and I are part of that group, and we are the coating specialists and asset integrity specialists within Henkel. So when we talk about common coatings, this is not by any means an all exhaustive list of different chemistries, but it's good to kind of get a baseline and understanding of how this all plays into high temperature, because not every solution is going to be the correct solution for your asset. And while something like epoxies are ubiquitous and everywhere, and it's used all throughout every industry in our daily lives, they're not the solution for everything, right? So you've got major classifications being organic, so carbon bonds, and then you've got inorganics like zincs and different metallizing or certain silicones. And then you have hybrids where they're combining multiple technologies, whether or not that's an inorganic or an organic, something like organic zinc would be an example of this, right? You've got an inorganic filler with a organic binder, or modified polymerics that we'll talk about a little bit more. And then also with the carriers and the types of coatings in your applications, this is very important when you're talking about, can this be airless spray? Does it have to be plural component sprayed? Is it heated? And that gets into 100% solids coatings versus solvent-borne coatings. Solvent-borne, so waterborne is just a subset of solvent-borne. Oil, your oil-reducible alkyds, right? Those are all solvent-borne coatings. We just classify them and commonly speak of them separately. When you talk about solvent, most of the time you're referring to VOCs, hydrocarbons, acetone, different alcohols, and then we talk about water separately because it has no VOC content. Lots of different chemistries, right? Talk about epoxies. There's coal tar epoxies. You got polyureas and then polyaspartics as the aliphatic subset of polyureas. We have alkyds and acrylics and nitriles and fluoropolymers and thermal spray, right? And then viscoelastics, things like Viscotac or Stopak, that are cold flow type coatings, which can be very useful in the anti-corrosion space. So when we look at temperature, how do we classify high temperature coatings? And then this is the Mitch version of this, right? Someone can probably has different definitions, but this is how I think about it. And different chemistries are going to peak at different temperatures, right? Of note, because I've included it in the first three sets there, would be epoxies, right? Epoxies, ubiquitous organic coating. Your basic epoxies, like your JB Weld type, two-component epoxy, your Mercaptan Cure epoxies, are going to typically have a maximum service temperature around 250 degrees Fahrenheit. You get into the bisphenol F and Novolac epoxies, and most of those are going to have a continuous operating temperature, especially for immersion service, around 350 degrees Fahrenheit. And then you get into the specialty multifunctional organics, like BMI resins, multifunctional epoxies, so glycidylamines, and then it's like cyanide esters. And those multifunctional epoxies, and then also different chemistries, the esters, right, can reach continuous operating temperatures of 300 C. A lot of organics, and you'll see it thrown around a lot, that organic coatings top out around 180 C or 200 C. And in coating space, most coatings that's pretty true because viscosity becomes an issue, right? But if you're doing plural component type coatings, or you're looking into composite repair type stuff, like our high temperature pipe wrap, those are organic resin binders, and they're going to have 250 to 300 C continuous operating temperatures. And then this is also where you're in this 550 Fahrenheit range is where your silicone hybrids are going to fall, silicone alkyds, silicone acrylics. Then you take another step up into that 800 Fahrenheit continuous operating temperature, and that's going to be primarily dominated by modified silicones, along with some basic higher temperature silicone polymers. And then after that, you step into the true kind of organics, which is going to be inorganics, which is going to be silicones, and then your modified polymeric silicones, multipolymeric matrices, and that's going to be your 1200 Fahrenheit continuous operating. A lot of these will be able to do temporary peaks, accommodating startups and different process interruptions up to 1500 Fahrenheit without negative impacts to adhesion or color gloss, etc. And then once you get above that 1200 Fahrenheit range, really this is where metallizing type coatings, thermal sprays, zincs, aluminum, magnesium, right? That's where this is going to be the primary solution. And then also you get into thermal spray silicone or ceramic oxide, so aluminum oxide and various different ceramics, instead of just pure like zinc metallizing. And then also as a tidbit, which is the opposite end of this spectrum, is going to be cryogenic coatings, sub-freezing coatings. Very important in the some of this is important, right, in the pipeline industry, but also aerospace, space applications, right? A lot of your silicones that are going to be in that 1200 Fahrenheit range also do very well up down to cryogenic temperatures. And then when you look in that negative 100 F C type situations, you're going to need you can get organic coatings like epoxies down to that temperature, but they're going to be using very specialized high-end cold temperature tougheners that have very good flow properties below negative 50 F. So. And then when we look at what we're bringing as Henkel and things we can talk about and industries we're serving and where all this goes, right? Really, almost any industry is going to have some amount of high temperature applications. You go to food and beverage, right? The high temperature in that environment may be cookers, right? It may only be 300 Fahrenheit, but for them, that's high temperature, right? It's enough to burn you, enough to cause problems, and enough that you're going to want to control that exposure. As far as applications go, I mean, every type of surface equipment, there's going to be something in that type of surface equipment that runs at an obnoxiously high temperature, right? Um, whether that's pipes, tanks, vessels, different process equipment, certain types of reactions happen at very high temperatures. So your process vessels themselves can be extremely high temperature rating, your flanges and valves and ancillary equipment that goes into that. And then when we look at different features of different benefits you're going to be considering, right? You want color stability, you want good adhesion, you want thermal shock resistance. Most of this equipment that's running at high temperature, so outside of like the asphalt industry where it's running 24/7, like a lot of it goes up and down. It cycles. Even your boilers, right? Your boilers have startups and shutdowns and blowdowns every day, and that's going to impact the amount of temperature resistance you need and thermal shock resistance you need in specific applications. And then there's also food safe technologies, right? Different liners, depending on if you're lining a cooker, right? The ratings for that food safe technology need to be different than ambient cure. Most potable water rated coatings, even like our Life Last DuraShield, right? It has a peak temperature limit for the NSF rating. While it can withstand peaks beyond that in other service, it voids its potable water rating. And then, so kind of cover this, but one of the big things, right? So high temperature, 1200 Fahrenheit, you're going to need protection. CUI is a major concern here. The corrosion sweet spot, right? You hear 120 to 320 Fahrenheit for corrosion under insulation. That's when you're getting rapidly accelerated rates of corrosion. Above 320 Fahrenheit, the water typically flashes off very quickly, any moisture entrapped in the insulation. Now, it will still maintain in that if it's absorbent in insulation like mineral wool, it won't fully dry out typically, but you're not super worried about corrosion while the equipment is operating above, say 350, 400 Fahrenheit. But in shutdown, startup cycling, right, you get below that 300 Fahrenheit, and now you're back in that rapid corrosion environment. And then dry fall is extremely important. We have solutions into this market that are dry fall coatings and can also be hot applied. So as an asset owner, especially if you're doing kind of an overcoat type situation, just trying to stay ahead, preventative maintenance, you can do these applications without setting up tons of containment, without having to do tons and tons of abrasive blasting. It can save you, as an asset owner, significant money, especially if you stay ahead of the corrosion and are doing preventative maintenance. So some of the products that I would like to kind of highlight today, and then we'll do a quick deeper dive on the Highland 827, which is kind of our workhorse into this high temperature space. So Mosscoat insulative coatings, right? 350 Fahrenheit. It's a high temperature for an acrylic coating. It's a specialty acrylic binder and allows it to have continuous operating of 350. Really, you can get at 375 comfortably, but once you get above that, you start running the risk of the heat getting reflected back in and creating a scenario where now you're at 425 or so. And at that temperature, the acrylic binder will start to harden and delaminate. So that's the temperature limit of that acrylic binder. But it is a high temperature for an acrylic, right? Your standard house paint acrylic latex is not going to go up to 350 Fahrenheit. When we look at the pipeline industry, right, most transmission pipelines are going to be below 100 C. There are some that are going to be in the 125 up to 150 C. So Canusa HBE-HT or Powercrete R150 for your ceramic modified epoxies. These are going to be high temperature pipeline coatings for AROs. Into the chemical containment and CUI coatings, you have the single coat, high build, Gripline 6700 HB, great for hot caustic service, up to 20 mils in a single coat. And so can save yourself a lot of money in processing if that's all the amount of temperature you need. And for that one, your immersion service is, depending on the chemical, is going to cap out at 300 or 350 degrees Fahrenheit. Dry heat is going to be 450 Fahrenheit. So this is an epoxy Novolac type chemistry. And then one step up from the Gripline 6700, we have ChemTemp 74HF, which is going to be also a CUI coating and a chemical resistant liner, 450 Fahrenheit dry heat, 300 up to 350 Fahrenheit for immersion service and a lot of chemicals. Some of them, your more aggressive acids will cap out at 250 or 300 Fahrenheit, but things we can discuss with you as an asset owner. And it does meet the SP0198 specs for CS3 and SS2. Then we get into our higher temperature. Now we're moving out of the organics into the inorganics, and we've got the silicone hybrids, best in class color and gloss retention type solutions up to 600 Fahrenheit continuous operating. Step up from that, we have the Tempercoat 888, which is a lower VOC version of the 850, Tempercoat 850, and those are going to be 850 Fahrenheit continuous operating with a gloss finish option. So good if you want that nice, pretty appearance. And then getting into the Tempercoats of 1000 and Stovemaster 1200. These are, think exhaust pipes, barbecues, exhaust stacks, things where you have external corrosion, but it's not an extreme corrosion environment. So you don't really need a very high build coating. You don't need two coats, right? So Tempercoat 1000 or Stovemaster 1200 are solutions into that up to 1200 Fahrenheit continuous operating. And then we get into the highlight of the day, which is going to be our Loctite 827 HB. So negative 300, 1200 Fahrenheit, excursions up to 1500 Fahrenheit, meets various SP0198 CUI specs. And we have significant, lots of testing on this product for scribe creep and salt spray, thermal shock resistance, CUI testing, very heavily used on like, continuous operating. So like the firing drums at asphalt plants, exhaust stacks, and then CUI applications where you are insulating this equipment for energy retention, but it's still running very, very hot. And so you have to protect against CUI. And then with that, kind of open here for quick discussion if you guys have some time and some questions.
All right, I am opening microphones as well. Feel free to put questions into the chat, into the Q&A. You can also open up your own microphone and verbally state it. We'll give you guys a couple minutes to get those in.
Someone's got to break the ice, right? How much does an elephant weigh?
I got one.
Yes.
Hey, good afternoon now. What kind of failures have you seen or with HDPE that you may be able to help assist? We've had failures from like high concentration chlorine, and we have the chem line for HDPE, and just wondering, do you have something that will help with that? Blistering. We've been seeing blistering.
This is a HDPE vessel.
Pipe. Yes.
So when we're looking at specifying, I guess, any sort of lining or solution, one substrate. So if the substrate is plastic here, that's extremely hard to bond to. There's solutions to make like a pipe in a pipe type situation where you're not as concerned about bonding, but what is kind of service and temperature, service environment would play into which system we recommend. But there are going to be solutions, possibly within our portfolio or outside our portfolio to reline HDPE.
David, are you seeing that blistering from the inside of the pipe or the outside of the pipe?
The outside.
Okay.
And I guess our concern was that it was, I guess the concentration of the chlorine, gas or whatever, it's supposed to be rated for it, but apparently it isn't. And what we've discovered was failure. So we're assuming that the other several hundred feet underground must be experiencing the same thing from.
Sure.
Yeah.
Okay.
So it's just an assumption. And have you ever seen any kind of pipe failure? Because I thought it was like a normal thing to use HDPE. Not a normal thing, but it wasn't irregular.
No, it's a growing market segment. This might be a great one to take offline and like you and I talk about it. But what temperature does that chlorine see basically?
I can get that for you, Doug.
Okay, great. So we'll do some research too on this one because it's definitely a great one to consider.
Okay.
Yeah.
Thank you.
And you bring up a good point, blistering on pipes or assets in general, right, is wall thinning. Coatings can only go so far to protect an asset. There are certain coatings with extremely high tensile strength that will kind of help you make a vessel in a vessel for like pressurized hydrocarbon type scenarios. But you're not with a coating, you're not getting a structural repair, right? So if you do need a structural repair because you've got wall thinning or blistering, or in the case of HDPE, you might have micro cracking, developing stress cracking. And so in that case, a composite type solution is probably more appropriate if you're just going to repair in place. And then
Which
so
might be one of those clock spring NRI solutions.
Yep.
Depending on what we find out, David.
And then I do see or potentially, DuraShield if you don't need the structural repair, but you want something with high tensile strength. So
we got another question from Clint Schroeder on for Highland 827 HB. What's the required surface prep? Also, what's the maximum application temperature?
Yep. So for most, we consider 827 HB a surface tolerant coating. What that means is there is, acceptable, better and best type surface prep, right? Better or best being if you're doing a near white metal blast, right? That's going to be best, or even white metal blast, solvent wipe, clean all your chlorides off, right? That's going to get you the longest term performance. Stepping down from that, if you can only do a commercial blast, we do have good results and have shown good results with that. Or in the case of overcoat type applications, if you can't blast, then doing water jet 4, so removing all tightly adherent rust, mil-scale, contaminants, solvents, oils, all that, and then overcoating because it is a silicone coating. What you'll find with a lot of coatings that are inorganic or something like an acrylic is they're bonding through ionic bonding. They're not bonding. It's not a mechanical bond like an epoxy. And so they can be much more surface tolerant, but your peak adhesion is a lot lower, right? Epoxies, you're typically wanting to see over 1,000 up to 2 or almost 3,000 psi of adhesion. Acrylics and silicones, you're going to be in that 300 to 500 psi adhesion range. And then applications, so we do have hot applications. I'm going to have to verify on the 827, but I believe it's either 600 or 800 Fahrenheit for the maximum temperature. We do reduce it with a slow release solvent if you're doing a hot application, but also like our CY coatings, the epoxy, the 74HF epoxy can also be hot applied up to 400 Fahrenheit. So, and then I saw Bobby had a question about highest or
biggest mistake owners make.
Yep, biggest mistake. And I think, and Jim's probably seen this a lot in the pipeline industry, right? We see it with Moscow. We see it with the high temperature coatings is really not taking the time to measure the temperature of your asset.
Yeah.
Like a boiler, piping, you might run a high oil system at 350. Well, you put Moscow on there, you don't address the steam, and now it's running at 450, and you have a failure. Coatings, right? You think of continuous operating 600. So, hey, I'm going to save a little money and time. I'm going to just overcoat with this 600 Fahrenheit modified acrylic, silicone acrylic. And turns out, well, hey, in startup, it actually sees 1,200 Fahrenheit. And so when you have a swing over your continuous operating that much, that's typically where we see failures and issues.
Yeah, I would say definitely that. I've seen that happen too. The other thing too is I think making sure that you're researching and that you're qualifying the products that you want to have contractors to apply or at least look at when they're applying. So that's the other aspect is just, talking to coating manufacturers, talking to subject matter experts, just to make sure that the systems that you're looking for, exactly what Mitch talked about, is this going to work or is there a potential issue if you have kind of a spike in temperature?
Yeah, the one thing that I would add to that is also just making sure that you're following all of your surface prep instructions on that tech data sheet. That's super important. It doesn't matter if it's a high temperature coating, really any coating that you're doing, any project that you're doing, that part is really, really important. So I always like to stress that surface prep piece. Make sure you're following all of the steps and you're doing that properly. That's going to give you the best outcome. Looks like we do have one more question. Do you have coatings that can be applied to hot surfaces on the run, and what temperature limits do they have?
Yeah, so we do most of our coatings, most of our dry fall coatings can be hot applied, and it really just depends on what you're doing, right? So all the way from the Moss coat, right, 350 Fahrenheit continuous operating, or some of our epoxies that can go 450 can be applied, hot applied, either to 200 or 300 Fahrenheit, or 400 Fahrenheit, and then you get into the silicone acrylics, and those are going to typically be 400 up to 800 Fahrenheit. We have beyond that, there, it's something we can discuss and maybe test and see. We do have data and some case history of going all the way up to peak operating if you can't do a shutdown in order to do the application. And so surface prep, right, just becomes, that's where overcoating and how do you get it clean if you're still running? Just conversations to have. And
Kevin,
then,
do you have a specific application you were thinking of that might help Mitch and Jim out a little bit?
We just have exchangers every now and then that, we really don't want to take offline that, maybe running at 250 degrees, 250 to 300 degrees that we, want to apply a coating to.
yeah.
Might be able to water blast them or something of that sort, or hand prep them a little bit, but, nothing that we can really take offline at the time
Right.
to take care of.
And that's a great application for, so the Highland 74HF under Mosscoat DTI. You get the corrosion protection from the epoxy, and then you get the insulative value and the personnel protection from the insulative coating. All that can be done while running. And especially with Mosscoat being a waterborne acrylic, applying it hot is almost preferred because you can do 80 to 100 mils in a couple hours opposed to a couple days. And so you can get much faster throughput if you're able to do it while it's hot.
Right. I'm not seeing any more questions. We are a little past time. Thank you, everybody, for joining us today. And thank you, Mitch and Jim, for presenting and going through the products. That was fantastic. If anyone does have questions after the fact, a survey will be going out to everyone that was here just to make sure that we're providing you guys the most possible value we can with these talks. You can also reach out to us at 248-735-7000 or email us at office@usigroups.com. Thank you again, everyone. Have a great day.
Thank you all.
Thanks, guys.
Thank you.